So section 5, chapter 8, is factoring special products. Basically what we're doing is we're looking at what are some special cases that if you catch it, you can save yourself some time because you'll be able to jump immediately to the answer. Otherwise, you're kind of stuck kind of like hacking your way through it and using one of the methods that we've been doing. But 8.5 is factoring special cases. And I'm going to start out with, it's really like two sections. We have kind of like two classifications of special cases. First one's going to be if you have a perfect square trinomial. So perfect square trinomial. I'm guessing the trinomial is going to be the more familiar part there. Trinomial is a polynomial with three clumps or three terms, right? The perfect square is going back a few sections where we had like a plus b in parentheses, and all of that quantity squared. That's the same, I don't think I'd write this, but that's the same when you see something like that. It's real tempting. Every year I see people that just write, oh, the answer is a squared plus b squared. But what that really becomes is a plus b times a plus b. And that was on the last quiz we had. I'm sure it'll probably show up on the test. There'll probably be like one token one like that on the test. But for that there, then you need to actually go through and FOIL. You're going to end up with a trinomial, not just a squared plus b squared. But what you end up with then is a squared. You want to remember the middle part? Plus, nice, 2ab plus b squared. So that's our first one. And our second one is going to be almost identical to that. We still have the a and the b and the squared. But now we're going to have a minus in there. And what's the only difference on the right side when we have a minus in between? Yep, it's the minus 2ab. You guys remember that better than I anticipated. Sorry for thinking you'd forget it. But in the past, everybody forgets it. So you guys are on the ball. Okay, so we have that there. Good. I'm going to jump down to an example and try it this way. But I'd maybe leave a little bit of space. If you leave a couple lines, maybe you'll want to squeeze in later, kind of like what I have squeezed into my notes. But here's kind of the application of that. So I'm going to say example 1, factor x squared plus 12x, x squared plus 12x plus 36. And if we were to totally forget that thing we just did in red and kind of treat this like we were doing in the last section, we could say, okay, that's going to be a couple binomials. We know at the very beginning we have to have x and an x, because x times x, when we FOIL, the first thing gives me my x squared, right? The signs have to be two positives, because a positive times a positive will give me that plus 36. And I'll end up with a positive number of x's. So then we'd say, all right, for my 36, that's 1 and 36, it's 3 and 12, it's 6 and 6, 4 times 9. But does anybody see what it has to be? 6 and 6, because now that gives me my positive 36 when I do 6 times 6, but also gives me a plus 6x for my plus 12x, right? Now, so that's kind of, push comes to shove, a lot of people I found, they just kind of do it the slow way, kind of like what I just did. But if you notice this red thing here, and I barely have enough room to squeeze it in there, kind of what should tip you off is if you have something here that's a perfect square. 6 times 6 is 36, right? And you say, okay, well maybe that's going to end up being this here. If this thing here is something squared, so it could be just an x squared, could be like a 4x squared or a 9x squared, because 4 is 2 times 2, 9 is 3 times 3. But if you see that, you could try to check and see, does it fit this pattern? Where maybe the easiest way to see it is something like this. This here, actually I'm going to switch to my red. This here, if I copy this top thing here down below, this is kind of like my a squared, right? Then I have a plus 2ab plus b squared, just copying down this thing right there. Well, if that's the case, what does b have to be? B has to be 6. So then if I have my a plus b quantity squared, it's kind of like saying, all right, I'm going to have a 6 right there. Both those signs are pluses, so it has to be a plus in the middle. And if a squared is x squared, a has to be x, right? A is in the same spot as the x. Making me nervous. But so it ends up just being that x plus 6 quantity squared, which is the exact same answer as we got if we'd done it the longer way. Here's what I had written before, and this could be helpful, this could be kind of worthless. What you could do is you could go over here to this side and go over here to this part, and you could say, well, if I square root this, so if I square root the a squared, that's going to tell me what a is, right? So basically you're square rooting x squared in our last case. If you square root the b squared, square root the 36, that's going to tell you what b is. And then you could just go back and check, does that fit in this middle term? So we could have said, well, square root of 36 is 6. Square root of x squared is x. Does it fit to say 2 times x times 6? Does that give me the 12x? Yes, so you can kind of see it works. Is that kind of, I'm getting a few nods. Let's try a different one. This is the kind of thing where if you do a couple, sometimes that helps. So I'm going to say factor 9x squared minus 48x. And if you don't end up mastering this at this point, you know, it's like go back, do it the slower way. You know, you can do it that way. All right, this here. So if we wanted to check and see if it fit, so this is most similar to my, see if I can squeeze it up above, a squared minus 2ab plus b squared. So what does b have to be? B is going to be 8, right? 8 times 8 is 64. What does a have to be? Perfect, I heard a 3x. Because you agree 3x times itself is going to end up being 9x. That is 3 squared is the 9, and then the x squared. Basically, that 2 applies to both things in there because it's multiplication. Okay, so you saw an a is 3x, and now you just have to say to yourself, okay, this middle part then, does that fit with 2ab? I prefer they said 2ba, but 2 times b is 16, right? Okay, and then a is my 3x, so I have 16 times 3x is 48x. Agreed? So if you know that that fits, well then, if I have this, I probably should have tried leaving more space up above, but we said that is going to be, skip it right down below. So that was a minus b quantity squared, right? Going back to here. If you want to do it the slow way you can, I'd encourage you to try it this way a few times. I think you'll get better at this as time goes on. In this section, at least, you'll get to the point where you start to recognize, oh, that's a squared, this is a square, it's probably going to work. And it'll take you less time. So we just found that it fits this right side right here. So we know that it has to equal the a minus b quantity squared. So then a minus b quantity squared, well, my a is my 3x, that's my a. My 8 is my b, so I end up with a 3x minus 8 quantity squared for an answer. Push comes to shove, go to the long way. Example 3 is an example of one that doesn't work. So you could just watch if you wanted to, but if you had to factor 25x squared minus 8x plus 1. What would tip me off to consider trying this new way is that I have this 25, that's 5 squared, right? And I have this 1, which is 1 squared. So when I see one like that, that'd lead me to believe, okay, maybe this is going to work. So if I have a squared, it's a minus, so it's that bottom one we had at the beginning, minus 2ab plus b squared. So if that's going to work, we'd end up with a minus b quantity squared out here. Okay. So a is going to be 5x. Okay. Because a squared is 25x squared. B has to be 1. So then you're just trying to see, all right, 2 times a times b, does that give me my 8x? So 2 times a is like 10x times 1, which is my b, is still 10x. It doesn't fit the minus 8x, right? So this one won't work doing this. So you'd have to go back and try to hack through it like we were doing in yesterday's section. Roman numeral 2, difference of squares. Of squares. So Roman numeral 1, doing it the old-fashioned way from section 4 is probably going to be easiest for you. I'd encourage you to try it. This way here is going to actually be really nice right out of the gate. So I'm going to say this here works with binomials with a minus in the middle. You put little quotation marks around my minus. Unfortunately, not all of them, but here's the equation. If you have a plus b in parentheses times the a minus b, we could go through and we could FOIL that a second. If we did, we're going to end up with a squared. Do you agree my outside is going to be a minus ab? And my inside would be a plus ab? So it ends up just canceling out. A plus ab and a minus ab are just gone. And then we're left with the L in FOIL gives me a minus b squared. So now whenever you have something that looks like this here, a nice number squared or even just an x squared, and then for the b you get like a 64, a 49, a 16, something that's a square, it's probably going to fit this nicely. So let's do a couple examples. So example 4, I guess we're doing technically. If you were to get a factor x squared minus 36. So see how it fits? Both of those things are something squared. So a has to be x. Okay. Okay. A has to be x. B has to be 6. Okay. So then all you need to do is take this part here and fill in your a and your b. So your answer then is going to be a was just an x, so an x plus b was 6 times x minus 6. And you're done. That's your answer. Isn't that at least beautiful? Oh, come on. Yeah. So at least I can convince you this is worthwhile, even if I couldn't convince you that with the first one. So if I were to do another example, try to make it look worse. If you have this 16x squared minus 144, do you agree? 16x squared is what squared? So that's really just 4x. That has to be a 12. Now if we're looking at this as though it's a squared minus b squared, you know that thing from the beginning, you have the minus there. We know the answer has to be just a plus b times a minus b. So a final answer then is going to be 4x plus 12. That's the a plus b times a minus b. So 4x minus 12. So that's the answer. Fair? One last one, kind of the non-example again. If I have this 7x squared minus 100, that's not going to work because, square root of 7 is something ugly. And so it's not going to end up working out for you, even though the 100 is a 10 squared. So when you see something like that, it's not going to fit nicely in our original, where is it? It's not going to fit nicely in this a squared minus b squared. So you might want to, in that very first statement, Roman numeral 2, works with binomials with a minus in the middle and 2 squares maybe. So 2 squares. And that could be like an x squared and a 36, like that first example we did here. Or it could be like a 16x squared, so 4x, 20 squared, and the 144. That's it for this section. So the assignment is this. I'm going to make a comment about one of them because I couldn't resist assigning it because it's a cool question. but I don't want you to actually go through and do it the long way like you might try. That would just be mean. Okay, so 57 to 64 is the last ones. A comment on number 48. So in here, number 48, look and find the trick. Don't like go through and do all the math behind it. So find the trick, and it'll save you a ton of time. And if you're afraid you can't find that at home, quick, do it in class, and I'll gladly help you if you're totally stuck. I'll give you some leading questions.